My name is Alan Hawes, and this is PSoC 101. In the last lesson, I talked about output pins. Now let's read some input. Start by making a copy of your first project. You can do that by using the Save As feature, which is available by right-clicking the original project to bring up the context-sensitive menu. This option is like Save As in any other document editor. It creates a new copy of your project and makes it the focus of PSoC Creator. Another option is to use the copy-paste functionality. Copy the project using the option in the context menu and then paste it into your workspace. You get a copy of the original project, which you can then rename. Be careful though, as all of the open files remain in your editor. The advantage of this approach is that both the original and the new projects are available in your workspace. That will be very useful down the road if you wish to refer back to the older design. However, make sure that you are editing the files in your active project. The active project is the one that PSoC Creator will build. That project is highlighted in bold in the Workspace Explorer. Files that are not part of the active project are grayed out, but can still be edited, so be very careful. To make a project active, right-click on it and set it to active. Remember, in the editor, the active project files have a white tab and the inactive project files have gray tabs. To make sure I do not edit the wrong files, I usually open up the schematic for my new project and then click Close All But This tab. Before I talk about the input pins, I have to change something from the first lesson that has been giving me the heebie-jeebies, which is definitely not a good thing. If you look at the schematic, you will see the pins, but there's no indication of what they do. If you showed this to a colleague, they'd think you were crazy, and they would have to rely only on your pin naming to understand the intended functionality. Let's fix that by documenting the LED circuit by using the library off-chip components that we provide. In the pin customizer, I will expose the external terminal. Then I'll search for a resistor and drop it into the schematic. I do not want to show the specific name and value of the resistor in this case because I'm really just interested in documenting the intent of my project, not the specifics of the Pioneer kit. So I will remove that from view in the customizer to make it easier to understand. Next, I'll add an LED and give it a handy name. And finally, I will add a power supply and hide its name so as not to confuse the user. To wire these items up, I use the wiring tool. Look how the cursor changes to show that you are over a terminal that will accept a connection. Just click to complete the wire. Once you've made the connection, the wire will remain connected when you move things around. This is called rubber banding. You can also create a wire by pressing the W key. I'll connect up the LED and power as well. Notice how I can just touch the terminals to make a connection. I don't actually have to use a wire. Okay, now I can repeat that with the other pins to make the rest of my schematic easier to understand. Remember to expose the external terminal on the blue and green LEDs as well. All of the components and wires that are blue are just for documentation and are not actually part of the project. Remember, blue components and wires are not part of the PSoC. They are only part of the documentation. Don't get confused. Now I'm going to add that input pin. Search for pin again in the component window and then find the input pin and drop it to the left of one of the output pins. I'm going to connect it to a button on the kit, so let's be good engineers and start with the documentation. In the pin customizer, I will enable the external terminal. Then I'll add a switch and call it SW2 because that's the name from the Pioneer kit, which you can easily see from the schematic in the Pioneer documentation that's available as part of the installation. Then I'll connect that pin to ground. Back in the customizer, I have to make some other changes. First, I need a software pin, just like we did in lesson 1. Next, I have to change the drive mode of that pen. The switch is connected to ground. That's also known as active low. When I press it, the input signal will go low. However, when I'm not pressing it, there's nothing to actually force the signal to high. So I will choose the resistive pull-up mode in the pen that will connect it to an internal resistor. This will ensure that an undriven pen reads high. One common mistake that people make is to forget to set the drive mode and to get frustrated that the pen cannot be read or that it reads erratically. I've done that to myself 1,000 times, so I'll try to keep reminding you about that problem from time to time. Now, I will assign the pen to the physical pen that's attached to the SW2 button on the kit. In C, I will change the old code to simply copy the state of the input pen to one of the output pens. When I build and program this design, I'll be able to control the LED from the switch. When I press the switch, it will light the LED. As before, please take the time to reproduce this project for yourself. There's no substitute for actually getting your fingers on the keyboard and doing the project. You'll find that you learn the material much better by doing it. Now, I think you should try to modify the C code so that the red and green LEDs alternate. When one turns on, the other turns off. These projects are how you will learn to use the PSoC most effectively. As always, you're welcome to email me at allen_hawes@cypress.com.